Right, question 5. So I've already put a bit of the working on. You know from my previous videos that this is the strategy that I prefer. It's just a visual way of doing the linear interpolation that is required to answer this question. So to get an estimate of a median in interquartile range, so really we're estimating the median and the quartiles, and from those quartiles we'll get the interquartile range. To do this with grouped data, we sketch a histogram and we want to fill half of the area. That will tell us where the median is. A quarter of the area, 3/4 of the area, that will be the lower quartile and the upper quartile. So the total area is 92. So for the median, we want half the area, and half the area is 46. So this here has area 8, this here has area 22, which means, you know, so far we've got area 30 altogether. These three boxes together would have area 66. I've put the cumulative frequencies in green here. It means that there's going to be some number along the bottom here, which is going to be our median. So that's, I guess, Q2, where I guess this has to be 16, right? Because we get to 30 from these two boxes and we really want to be at 46. So this area here has to be 16. So the estimate for the median will be 1005, because that's where we start. We start at 1005 plus this area divided by the width. The width is going to be the area divided by the height. Apologies. So I'm going to have 16 divided by 36 over 5. So 16 over 36 over 5. So this is my Q2 estimate. I'm just gonna do that on the calculator. So 1005 add and then 16 over 36 fifths gives me, sorry, I've pressed times instead of add, 1007.2 to 1 decimal place. Okay, so somewhere between 1005 and 1010 is Q2, and the best estimate is 1007.2. Right, for Q1, we'll do Q1 first. So for Q1, we'll do 92 over 4, which is 23. So we want an area of 23. So that's going to be somewhere in this box, because this is 8, this is 30 altogether. So 23 will be somewhere in here. And if we've already got 8, it means we want another 15. So this is 15 that goes there. This is the area that we want this box to be here. This is our estimate of Q1. So I'm going to have 1000 this time, because we're starting over here on 1000, plus this width, which will be the area divided by the height. So 15 divided by 22 fifths. And on the calculator, that is 1003.4 to 1 decimal place. And then finally for Q3, I'll have 3/4 of 92, which is 69. And so that's just 3 more than this 66. So that goes in there. So there's 3 that goes there. So what you've got to think is really it's all of these boxes from the left getting coloured in, and then this extra 3, and then that will be the area that we want. So it's going to be 1010. Oh, by the way, I'll just pause for a second here and just say, look, if I'm going too fast here, there is a video that goes into this in quite a bit of detail that shows you exactly how to do this. So I would recommend watching that as well if you're stuck on this, finding this tricky, because I go through it in more detail. So anyway, it's 1010 plus 3 over the height, which is 3. So this is just 1011. Exactly. And then those are those. The answer to the interquartile range estimate. Oh, sorry, I'll just for completeness, let me put a little arrow and write Q3. Seems like a good idea. And then interquartile range. Again, this is an estimate. And if you think about it, it's an even worse estimate than either of these quartiles because it's combining two estimates. So, but it's still an estimate, and it's still the best estimate that we've got. We have to do Q3 take away Q1. So we do 1011 take away 1003.4. And if we actually use the more accurate numbers and then round, well, we get about 7.59 or about 7.6. I'm going to write 7.59 to 2 decimal places here. Okay, so quite a few people got 5 out of 5 there, which was really good to see. Right, this one was answered a little bit less well. Let me just kind of tell you what to do here. So Q1 minus 1.5 times the interquartile range. So let me just remind you here. Q1, let's write it down, is 1003.4. Q3 was 1011, and the interquartile range, I'm going to use 7.59. You could also probably use 7.6. It's not going to change the answer. And so you do Q1 minus this, so you do 1003.4 minus 1.5 times 7.59. So this is 992.015. That's the lower one. So this is like the lower. And then the higher one is 1011 plus 1.5 lots of 7.59, and this gives you 1022.385, and that's like the upper. And then the idea is that if you have any data that might be less than this, then there could be some outliers. If you have any data which is greater than this, then they would be considered outliers. But if you actually look at what it would mean to be less than this, we can't be, right? Because the lowest pressure possible was 995, according to this table, and the greatest pressure possible was anything up to but not including 1020. So since these are actually out of the range of this table, we can conclude that there are no outliers. Okay, so that's that. That's question 5. Right, briefly, number 6. It's a negative correlation. Visibility increases as humidity decreases, or you could say it the other way around. It's fine. The interpretation of the gradient of the regression line means to put it into some context. If it was, time and distance, what would the gradient mean? It would be distance over time. You got to think back to what the gradient of a straight line is really on about, and that would be speed, wouldn't it? So that would be the interpretation there of what that gradient would be. Here, however, it's not speed because it's not distance and it's not time. It's what is it? It's like humidity per visibility. So it's a bit weird, isn't it? So you just say something like, and I'll actually write the answer in, for every increase of 1 dm of visibility, humidity decreases by 0.003%. That's the interpretation of the gradient line. If you need more help on that, by the way, I had a question from 2 people about this with your kind of practice revision questions, and I'm quite happy to just copy and paste my reply to them if you need a bit more information on that. Right, so what have we got here? H is 100.9 minus 0.003 V. You substitute V is what, 93, and you rearrange. Oh wait, no, I'm getting that the wrong way around. You substitute H is 93, and then you solve the equation. You should get V is 2633.3. Right, and then part D. What goes wrong when we are estimating the daily maximum relative humidity when the daily mean visibility is less than 300, so somewhere down there. So part point one, so state two problems. Problem number one is, and it's a key word that you would need to get in there in a question like this, is that extrapolation is problematic. It's bad. It's dangerous. It's not a good idea. You should not extrapolate unless you can be very, very confident, basically, and you've got other good supporting reasons for doing it, which you certainly not in this context. You don't have that. So in general, you've got to say extrapolation is dangerous. It's problematic. We don't know if the trend will continue. You need to get that key word extrapolation in there. Okay, the kind of the opposite of extrapolation is interpolation, and that would mean, okay, I've got my trend line, making estimates within the data. Now that's generally speaking an okay thing to do. Extrapolation, however, no. The other problem is the trend line, and indeed, if you use the equation of the line of best fit, if you plug the value in, you'll end up with a percentage relative humidity greater than 100%. Which would mean that more. I mean, actually, I don't know. I'm not a scientist, so I don't know for sure what it means. But I would think that it would mean, it's like what percentage of the air has, well, has water in it. I guess I don't know, but if it can't be more than 100%, I'll just stop talking because I don't want to say anything wrong, and I don't want to say anything else about that. Right, number 7. Okay, you need to say that we need a quarter of the stations, and for the exam, the real exam, you need to say that you use a random number generator to select the start position or whatever it might be. When you're saying, look, I need to choose something randomly, if there's some way of numbering them, you use the phrase, I'm using a random number generator. Okay, so we would get a random number between 1 and 4. We wouldn't just pick one out of our head. We'd use a random number generator. That would tell you whereabouts to start in your list, and then you need every fourth one. So, depending on how you read the list, by the way, if you go across or if you go down, you basically, I gave you the marks. People did generally speaking fine on that. Okay, part B, give the definition of a simple random sample. So a simple random sample is one where every possible combination of objects is as likely as the other. Okay, everything, no matter what we've already picked, has the same, they don't get more chance or less chance, right? It's the same. And this is not a simple random sample because once you've picked the first one, the rest are all fixed. Okay, the rest are all fixed. And another way of thinking about it is, was any combination of the towns just as likely as any other? No, I couldn't have had, there are plenty of combinations that by following this method you would not be able to get. Right, okay, now this last one, when you are representing things, so let me just make sure I'm reading this correctly. How can we ensure the sample is representative of towns in both areas? So we use what's called stratified random sampling. And it tells you 8 of the weather stations are in the north, the rest are in the south. So we've got 8 and 12, which means we want it to be proportional. So we're going to need a quarter. So remember, it was a quarter of 8. We're going to need 2 from the north, and this is where some people missed out on the second mark here. It's not a particularly nice question. You would get much more precisely written questions in the actual exam. You needed to say how many from the north and from the south would you need. A quarter of 12 would be 3 from the south. Right, last question. What was the median length of average weight? So you go halfway between 30 and 0 was 15. So along to 15, down, and this is 14. So 14. You were allowed anything between 13.5 and 14.5. And then this question, it's a horrible scale. Very difficult to see what's going on. But basically, if we're being as careful as we can be, we would establish that this is 28 to there. This is 23. This is 17. And this is 3. Now, I did award partial credit if your numbers still made sense, and if you then used your numbers in the next part, I just gave you full marks for that part as long as the working out was right. Okay. Again, in the real thing, in the real exam, you're not going to get a graph that looks like this where it's so open to interpretation. Okay. So basically, 30 take away 28 is 2, 28 take away 23, we put 5 here, 23 take away 17, we put 6 here, 17 take away 3, we put 14 here. So this is actually what the numbers needed to be that went in the table. And then it says we want to calculate the variance in the average daily weight. So let me just take a screenshot of this and I'll quickly answer this question. Right, so what you want to do is you want to do the midpoints. So you got 5, 12.5, 17.5, 25 and 35. So the idea is it's an estimate. We're going to pretend that these 3 were all 5, these 14 were all 12.5, these 6 were all 17.5, these 5 were all 25, and these 2 were all 35. Of course, they might not have been, right? There'll be some variability, but this is our best estimate, okay? So we're going to need the mean. So we're going to do frequency times the midpoint. So we'll do 3 times 5, which is 15. I'm just gonna look at this for my numbers here. Then I've got 175, 105, 125, and 70. So that's the frequency times the midpoints. I'm also going to need my frequency times the midpoints squared, okay? Because I'm going to be working out the variance. What I would have is I'd have 3 lots of 5 squared. I'd have 14 lots of 12.5 squared. I'd have 6 lots of 17.5 squared, etc., etc. If you need a reminder on this, by the way, there's a much clearer, slower example in the standard deviation video that came out a while ago. So if I square 5, I get 25. I have 3 of those, so there's 25 there. And let me just write these numbers in that you get. You get this, 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 and this, right? If you square 35 and double it, you get that. So with all these numbers here, we're now in a position where we can work out the variance. Okay, we'll start by working out the mean. So we add up the frequency times the midpoints and divide by how many. This is going to be x bar. And we end up with 49 over 3 if we do this. So if I do 15, add 175, add 105, add 125, add 70, and divide by, 30, you get 49 over 3. So that's the mean. And then for the variance, you need to add up the frequency times the midpoint squareds, divide by how many, and then divide by x bar squared. Now, unfortunately, I think one person did all of this and forgot the squared here. It's very, very important, and it's such an easy mistake that you can make as well. So just try to be really, really careful. So I haven't even put like extra working in. I just put the answer. So I think you get 1003 over 18 if you work this out, which is about 55.7. If you need any of those in any more detail, you email me. You send me an email saying extra help, please, and then you tell me the question you need more help on, and I will get back to you. I am actively encouraging that. It's really, really important that you understand everything that was in this test, okay? Really, really is. Please do look at my previous videos to do with this chapter. In particular, you know, if you didn't get any of the marks to do with working out the standard deviation, then that is something clearly you do need to know how to do. It needs to come to you as naturally as just working out the mean or working out the median of some numbers, right? You need to know how to work out the standard deviation, okay? It is a more complicated formula, but it is not a really horrible, massively complicated formula, okay? It is something that you have the capacity to memorize and should have done quite a bit of practice of in the build up to this. So if this is something that you've forgotten how to do, you need to revise, please look back at those videos. They will, as I said before, be linked in the description. And hopefully this was useful. Hopefully this has helped. And I will see you later. Bye.